Hello everyone. So in today's class, we are going to develop the essential mathematical background that we need to understand the subject. Okay? They include topics like Supremum, what's the concept of Infimum, what's a norm, what we mean by vector norms, what are matrix norms, and so on. So we'll get into the details. Supremum and Infimum. Supremum and Infimum. And Infimum. Okay. Let A and B be two real numbers. Let A and B be two real numbers, such that B is greater than A, B is greater than A. Okay. Now we can define two intervals. One is a closed interval and one is an open interval. Okay. So consider a closed interval. Closed interval. Okay. Closed interval is denoted with square brackets, A comma B. Okay. This is such defined like this: X, such that X is a real number. Okay, wherein X lies between A and B. Okay, X can take values from A to B and any values in between. Okay, and now we will consider an open interval. Open interval. Open interval is denoted with round brackets, A comma B. Okay, that is defined like this: X, where X is any real number, such that A less than X less than B. Okay. So you tell me, consider the closed interval first. Okay, what's the maximum value of A? Maximum value of X? Maximum value of X is nothing but B, right? Because the highest value, the limit is B. What's the minimum value? Minimum value of X is A. Okay, now what is the maximum value of X in the open interval or minimum value? You cannot define that. Okay, because see, X is less than B, greater than A. Okay, so X is less than B, it is not equal to B. So here you cannot precisely define the maximum value and the minimum value, but you can only define some bounds, some upper bound and lower bound. Okay, here it is not possible. Here it is not possible to precisely define the maximum value and minimum value. The maximum value and minimum value. Okay, but you can only define some bounds here. Okay, but only upper and lower bounds can be defined. Okay, say for example, 5 less than X less than 10. Okay, so X is less than 10. Okay, so X is less than 10 means X is obviously less than 20. Is it not? Or X is again less than 30. Right? So these are all upper bounds. Right? But 10 is the least upper bound. Okay, 10 is the least upper bound. Right? X less than 10 means X is less than 11. X is less than 15. X is less than 20. X is less than 30. So these are all bounds, upper bounds. But out of which 10 is the least upper bound. Okay, so that is why it is called a supremum, the least upper bound or supremum. Okay, so let's continue. Any number greater than B, any number greater than B, any number greater than B is an upper bound of X. An upper bound of X, but B is the least upper bound. B is the least upper bound. of X, and that is called supremum. Supremum or sup of X. Okay. Similarly, X is greater than 5. Okay. X is greater than 5 means it is obviously greater than 4. It is obviously greater than 1. It is obviously greater than 0.5. Right? These are all the lower bounds, but 5 is the greatest upper bound. Okay. 5 is the greatest upper bound. So that is why it is called an infimum. Okay. Similarly, any number smaller than a is a lower bound of X. A lower bound of X. However, a is the greatest lower bound. Greatest lower bound. And is called infimum of X. And is called infimum of X. Okay, so the greatest lower bound is called infimum, and the least upper bound is called supremum. That's the idea behind infimum and supremum and infimum. Okay, now let's jump into norms. Norms. Okay, norm actually is a number that gives the size of a quantity. Okay, norm is a number, right? Norm is a number that gives the overall measure or quantification of the size of a vector. It may be a matrix, can be a signal, or a system. Keep in mind here, by the size of matrix, we do not mean how many rows and how many columns. It is the size of each element of the matrix. Okay, it is a number. Norm is a number that gives the overall measure, or it quantifies the size of a vector, matrix, signal, or a system. Okay, so what is how is norm defined? A norm of E bar. Okay, E bar may be anything. Okay, which may be vector, matrix, signal, or system. A norm of E bar is a real valued number, is a real valued number, and that is denoted by, this norm is denoted by two vertical bars, okay, both on the right side and the left side, okay, with the following properties. With the following properties. With the following properties. Okay, 1. Norm of E bar greater than or equal to 0. It will be always. Okay, when you take the norm of a number, it will be either 0 or greater than 0 always. Okay, 2. Norm of E bar equal to 0. That implies the quantity itself is 0. Okay, norm of E bar equal to 0 implies that quantity itself is equal to 0. Okay, then 3. Norm of alpha times E bar will be equal to an absolute value of that alpha into norm of E. Okay, where alpha is any real or complex number. Alpha may be real or alpha may be complex. Okay. If you want to take the norm of alpha times E bar, then it is nothing but it's equal to mod alpha into norm of E bar. Then fourth property. Norm of E1 plus E2 will be less than or equal to norm of E1 plus norm of E2. Okay. So these are the four properties which a norm has to satisfy. Okay. So now we will go to vector norm. Vector norms. Okay. Suppose you have a vector A. Okay. It has an m number of elements, right? So that means there are m rows and one column. Okay. Vector with m elements. Okay. So let AI be the each element. Okay. So see, what is our A bar? A bar is something like this. A1, A2, etc. AI, A. Okay. So AI is the ith component. Okay. And mod AI is the magnitude of absolute value of the ith component. Okay. A is the absolute value of the absolute value of AI. Okay. Then P norm is defined like this. Vector P norm is given by this. Sigma I mod AI whole raised to P whole raised to 1 pi. This is how the P norm is defined. Okay. So P norm of any vector A bar is nothing but Pth root of sigma I mod AI whole raised to P. Okay. Now, what will be the one norm? How can you define one norm from this? What will you get? One norm will be what? 1 by 1. So this becomes sigma I mod AI. Okay. Sigma I mod AI. So one norm is the sum of the absolute value of the vector matrix. One norm is the sum of absolute value of the vector elements. Okay, as an example, let us try this. Suppose you have a vector B bar, okay, where B bar is 1, 3, minus 5. Find what's the one norm? What's the one norm? Find. How will you find? You take the absolute value of each component, take the sum. So you will get 9. Okay. Sigma I, you will get 1 plus 3 plus 5, which is nothing but 9. Okay. Now, what about 2 norm? So this is one norm. What will be 2 norm? 2 norm will be square root of sigma I AI square. Okay, 2 norm. How will you define that? It is nothing but square root of sigma I AI whole square. Okay. So what is this? This corresponds to the shortest distance between 2 points, you can say, right? X square plus Y square. Okay, suppose you are here, right? This is the shortest distance. So this is X and this is Y. This represents the shortest distance basically. Okay. This norm corresponds to the shortest distance. This norm corresponds to the shortest distance between 2 points. Okay. So let us try to find what's the 2 norm of this vector. What is the 2 norm of this vector? What will you get? Root of sigma I bi square. Okay. So what will you get? Root of 1 plus 9 plus 25. That's nothing but 5.916. Okay. So one norm was 9. That measured the size of vector in some sense. 2 norm, the size is measured as 5.916. Okay. Then we have what is called the infinity norm. Okay. What is infinity norm? Infinity norm is defined like this. Maximum I is the maximum of the absolute value of the element. Okay. Largest element magnitude. Okay, so what is our B? Our B was 1, 3, minus 5. So what will be the infinite norm here? It will be nothing but 5. Okay, it's the largest element magnitude. Okay, so in MATLAB, there are some commands. Norm A comma 1, that gives you the 1 norm. Okay, in MATLAB, right? You can try this in MATLAB as well. Then norm A comma 2 will give you the 2 norm. Okay, and norm of A comma INF will give you infinite norm. Okay, you can try in MATLAB. Fine. So these are the main types of vector norms. Now we'll go to matrix norms. Matrix norms. Matrix norms should additionally satisfy one more property. Okay, what we saw was for vector norm. Okay, so matrix norms. Okay, well, it has defined the property. Consider a constant L by M matrix, L cross M matrix A. That means there are L rows and M columns. Okay, so the norm of A. Okay, it should satisfy the following property. One, norm of A should be greater than or equal to 0. Okay, similar to the vector norm property, norm of A should be greater than or equal to 0. Then norm of A equal to 0 if and only if that matrix itself is 0. Okay, similar to property number 2. Right? Then alpha times A or K times A. Right? That what should be that? That should be absolute value of K into norm of A. Okay, for any scalar K. For any scalar K. That also comes from the norm property, norm definition, norm properties. Okay, then again, fourth property. Fourth property. Norm of A1 or A plus B must be less than or equal to norm of A plus norm of B. Okay, again, that is similar to the norm property. Additionally, it has satisfied the submultiplicative property. That means norm of AB will be less than or equal to norm of A into norm of B. Okay, so these are the properties to be satisfied by matrix norms. Now let us see some types of matrix norm. First one is sum matrix norm. Sum matrix norm. Okay, sum matrix norm is defined like this. Sigma I comma j mod aij. What is aij? Aij means so you see our matrix A means you have L rows. Okay, so that means say A 1 1 A 1 2 etc. up to A 1M. Okay, so A21, A22, etc. up to A2M. Like that, A, L1, A, L2, etc. up to A, Lm. Okay, so Aij means the element corresponding to the ith row and jth column. Okay, that is Aij, right? So this is the sum of element magnitudes. This is the sum of element magnitudes. Okay, that is what is sum matrix norm. Then next one, Frobenius norm or Euclidean norm. Frobenius norm or Euclidean norm. Okay, that is defined given by this expression. Sigma I comma j mod aij square. Okay, that is also equal to root of trace of AHA. What is H? H means complex conjugate transpose. In case if your matrix consists of complex elements, then you have to take complex conjugate transpose. Complex conjugate transpose. Okay. What is trace? Trace means sum of diagonal elements. Okay. So if you have a matrix A with complex elements, then you find its complex conjugate transpose, multiply the two, take the sum of the diagonal elements, square root of that. That will give you the Frobenius norm. Okay. So as an example, let us try one example. A equal to 1, 2, minus 3, and 4. Okay. Find what is the sum norm and Frobenius norm. How will you find the sum norm? How will you find the sum norm? Find. That is nothing but sigma I comma j aij. That means 1 plus 2 plus 3 plus 4. You will get 10. Okay. And how will you find the Frobenius norm? Find the Frobenius norm, square root of this thing. Okay. So what do you get? Square root of 30. Right? So 1 plus 4 plus 9 plus 16. Okay. 10. 26, 30. So root 30 you will get. Okay. So this is what is called Frobenius. Okay. Then we have what is called one norm. One norm. Okay. One norm gives the maximum absolute column sum. Gives the maximum absolute column sum. Okay, that means norm of 1 is nothing but maximum of j sigma I mod aij. Okay, or if you simply put, what we can do, we sum the absolute values down each column and take the biggest value. Put simply, we sum the absolute values. We sum the absolute values down each column, down each column, and then take the biggest value. Okay, for example, again, a equal to 1, 2, minus 3, 4. Okay, what will be the one norm? Tell me, how will you find the one norm? You will just take the absolute value down each column. So what do you get? 4 and 6. Okay, so maximum value of that. That's nothing but 6. Okay, it is nothing but 6. Right? That is what is one norm. Now we have what is called the infinity norm. Infinity norm. Okay, infinity norm gives the maximum absolute row sum. Gives the maximum absolute row sum. Okay, so that means infinity norm is defined like this: maximum I sigma j mod aij. Okay, so that is what we do. We sum the absolute values along each row and then take the biggest value. That is, we sum the absolute values along each row and then take the biggest value. Okay, again for this example, a equal to 1, 2, minus 3, 4. Right? What is the infinity norm? Find. What's the infinity norm? Infinity norm is 7. Okay, you take the absolute value of each elements in you take the absolute value of elements in each row, add it up, and so here what will you get? 3 and 7. So maximum of that is nothing but 7. Okay. Then next one is spectral norm or 2 norm. 2 norm or spectral norm. Okay, that is given by root of lambda maximum of AH transpose A. Okay, later you will see that this is what is called the maximum singular value. We will see that later what it is. Okay, so this is what is called 2 norm or spectral. Fine. So in MATLAB, there's a command. There are commands to find these norms, matrix norms. If you want to find one norm of matrix A, that command is MATLAB command is norm of A, 1. Similarly, 2 norm can be found using norm of A, 2. Okay. Keep in mind you have to input A as a matrix. Then only you have to use this command. Okay. So if you find the 1 norm, the command is norm of A, 1. Norm of A, 2 will give you the 2 norm, and the infinity norm is given by norm of A, in. Okay. So we will stop here today and meet again for a new lesson in the next class. Thank you.